For more than a century, James Clerk Maxwell's equations have shaped every corner of modern physics, from the light in your room to the signals that power your smartphone. But today, they might be doing something far more extraordinary. A research team claims they've engineered a spacecraft prototype so advanced it appears to generate propulsion without consuming traditional fuel. No rockets, no ion engines, no propellant tanks. Just pure, elegant physics. And if their results hold up, this could be the moment humanity unlocks the holy grail of cosmic exploration, a form of propulsion that seems, at least theoretically, limitless. To understand why this announcement has turned the scientific world upside down, we need to go back, way back, to the 1860s, when Maxwell introduced a framework of equations that describe how electric and magnetic fields dance together. So when a group of physicists claim they've used Maxwell's principles to create a propulsion system that doesn't rely on ejecting mass, it's no surprise that experts everywhere are leaning in. So, what exactly did this team build? They call it an electromagnetic reaction chamber, a device that manipulates electromagnetic fields in an asymmetric configuration. The idea is simple to describe and incredibly hard to achieve. By shaping the behavior of fields inside the chamber, the team claims to induce a directional force on the spacecraft itself, not by pushing against air, not by expelling propellant, but by interacting with the underlying geometry of space-time. If this sounds like science fiction, that's because it always has been. According to their report, the prototype demonstrated a small but measurable thrust inside a vacuum environment, where traditional explanations like air movement or heat gradients shouldn't apply. Enough to suggest something real may be happening. Something that challenges a long-standing assumption that all propulsion must obey the rocket equation. And that's where the excitement and skepticism begins. Skeptics argue that the observed thrust could still be an experimental artifact. Thermal noise, electromagnetic interference, or even measurement errors. Others insist the concept violates conservation laws unless the system is interacting with the vacuum itself, a possibility that dances dangerously close to what mainstream physics calls taboo. But here's the fascinating part. Nothing in Maxwell's equations explicitly forbids complex electromagnetic structures from generating motion through their interaction with fields. In other words, this idea isn't impossible. It's unexplored. Now just imagine that the thrust measurements are real, that this technology scales. What could humanity do? We could build spacecraft that accelerate continuously, not for minutes, but for months or years. Journeys to Mars shrink from 7 months to a few weeks. Trips to the outer planets become routine. Interstellar probes, once the dream of science fiction, suddenly edge into the realm of engineering. And for the first time in human history, distance stops being our greatest limitation, that it's still early. There's more testing to be done, more eyes needed on the data. But if Maxwell's equations are quietly holding a secret that we're only now learning to unlock, then we might be standing at the threshold of a new era. As the research team's results quietly ripple through scientific circles, a new sense of contemplation begins to settle across the global community. Researchers, engineers, and thinkers from a wide range of fields start examining the implications with a mixture of patience and belief. They do not rush to conclusions. Instead, they move with thoughtful precision, studying data, refining instruments, and testing smaller variations of the electromagnetic chamber. And as each new experiment brings a more subtle evidence pointing toward the same gentle pattern of thrust, the conversation starts shifting from "is this real?" to "what does this mean for us?" The atmosphere becomes one of calm discovery, as though humanity has stumbled upon a long-forgotten doorway gently opening by itself. In universities and research institutes, young scientists gather around whiteboards, sketching new forms of spacecraft architecture that no longer rely on heavy fuel tanks. These designs are graceful, almost organic, shaped by fields rather than fire. Instead of engines roaring with flame, these vessels would glide forward on silent, steady waves of electromagnetic interaction, like ships moved by soft, invisible currents. Professors who have spent decades teaching classical physics find themselves revisiting old chapters with renewed curiosity, realizing that Maxwell's equations may contain layers of beauty and possibility that the world had not fully explored. The discovery becomes an invitation to look again, to question with kindness and wonder rather than skepticism alone. Meanwhile, space agencies worldwide begin to imagine missions that were once considered dreams too distant to pursue. Concepts for probes to the outer solar system evolve into plans that could send them there in a fraction of the time. Astronomers envision a chance to explore exoplanets not centuries from now, but perhaps within the span of a single human life. The idea is not that this new propulsion system defies the laws of physics, but that it harmonizes with them in a way humanity had not recognized before, much like a musical instrument that, after centuries of familiarity, suddenly reveals a new note. It is a gentle reminder that the universe still holds wonders waiting to be discovered by those patient enough to listen. As the possibilities grow, so does a quiet sense of responsibility. Scientists emphasize the need for transparency, collaboration, and shared knowledge. They understand that any technology capable of changing the course of human exploration must be developed thoughtfully, with attention to safety, ethics, and long-term impact. This moment becomes not just a scientific milestone, but an opportunity for the world to move forward with unity and grace, recognizing that breakthroughs carry their greatest meaning when they are used to uplift all of humanity. The story of Maxwell's revolutionary spacecraft becomes a story of cooperation, reflection, and hope, a chance for nation scholars and explorers to walk together toward a peaceful and expansive future. And as all of this unfolds, the prototype in the quiet research facility continues its tests. Each gentle pulse of electromagnetic energy, each whisper of unassuming thrust, reminds the team that they may have touched upon something subtle yet profound. The spacecraft itself, still small and experimental, sits at the center of a new chapter in human curiosity. It represents more than technology. It symbolizes a patient journey toward understanding, a journey guided not by haste, but by the steady, thoughtful pursuit of truth. It stands quietly in its chamber, waiting for the next moment when it will once again reach gently forward into the unknown, carry with it the dreams of the species ready to explore the stars with calm determination and open hearts. As the prototype rests quietly in its chamber, the research facility around it begins to hum with a newfound sense of purpose. The scientists who once approached the project with cautious optimism now find themselves filled with gentle anticipation, as though they are witnessing the early dawn of a long-awaited moment. In laboratories adjacent to the testing hall, engineers refine delicate instruments designed to measure the faintest of forces, adjusting sensors and recalibrating detectors with care. They move slowly, aware that each improvement brings them closer to understanding the subtle elegance of this propulsion effect. Their work does not feel rushed or pressured. Instead, it feels as if the entire facility is breathing in harmony, all of its efforts converging toward a single point of clarity. Beyond the walls of the laboratory, a quiet transformation begins spreading into the wider world. Scholars from distant universities request access to the research papers, eager to explore the mathematical relationships shaping this new technology. Philosophers, writers, and educators start composing thoughtful reflections on what it might mean for humanity to explore space without haste or fear. The public, too, responds with curiosity rather than anxiety, asking respectful questions and expressing a sense of peaceful wonder at the thought of vessels gliding through the cosmos on waves of electromagnetic finesse. This shared atmosphere of calm interest weaves people together, reminding them that discovery is at its best when it inspires unity. Space agencies gather in conferences, exchanging ideas with open minds and open hearts. Rather than competing, they find themselves appreciating the possibilities of a collective vision, one in which knowledge is shared generously, and the mysteries of the universe are explored for the benefit of all. Teams of scientists imagine new missions where spacecraft travel not in short bursts of acceleration, but in continuous, gentle motion, like celestial sailboats drifting steadily across interplanetary seas. Engineers begin designing graceful craft with broad, curved surfaces meant to guide electromagnetic fields with precision. These vessels no longer resemble machines of force, but instruments of harmony, structures meant to move with the natural flow of physical laws rather than resist them. Meanwhile, back at the original facility, the lead researchers begin preparing for an important next step, the first extended duration test of the prototype. Instead of short pulses, the chamber will be allowed to sustain its electromagnetic configuration for longer periods, enabling the team to observe the evolution of the thrust with greater clarity. The preparations unfold with quiet discipline. Each cable is checked, each sensor lined, each parameter reviewed with patient attention. The team understands that they are not merely testing an object. They are beginning a dialogue with nature itself, one carried out with respect and attentiveness. As the moment of the test approaches, the lights dim slightly in the chamber to reduce interference, and a tranquil silence settles over the room. The prototype sits in the center, surrounded by instruments that wait patiently for their role in the unfolding story. When the system activates, the electromagnetic fields begin forming their intricate pattern, glowing softly like a delicate aurora suspended inside the chamber. The scientists observe the displays with calm concentration, watching as the measurements begin to drift gently in a direction consistent with previous experiments. The thrust is still faint, still modest, but undeniably present, persistent, reliable, and beautifully steady. And as the test continues, extending far beyond the duration of any previous trial, a quiet realization spreads among the team. They are witnessing something that is not only repeatable, but stable, something that might indeed form a foundation of future, where spacecraft move gracefully through space with continuous, peaceful propulsion. The room feels warm with shared hope, as though the gentle motion of the prototype is reaching out to remind everyone that progress can unfold quietly yet profoundly, like a soft tide shaping the shore over time. As the extended test concludes, the prototype powers down, and the room is filled not with noise or celebration, but with a quiet, reflective energy. The team gathers around the instruments, reviewing the data one last time. Every measurement confirms what they had hoped. The thrust was stable, consistent, and precisely aligned with the electromagnetic patterns they had designed. In that moment, there's a profound sense of fulfillment, not a victory over nature, but a harmonious partnership with it. Humanity has taken its first careful, deliberate step into a new way of moving through the cosmos. Word of the achievement spread steadily, reaching not just scientists but educators, students, and curious minds across the world. The discovery inspires books, lectures, and conversations that weave together imagination and mathematics, philosophy, and engineering. People begin to envision a future where space is not a distant, unreachable frontier, but a place that can be explored thoughtfully, gracefully, and with a sense of wonder. Children sketch spacecraft gliding silently among the stars. Universities create programs dedicated to electromagnetic propulsion. Nations collaborate to explore farther than ever before. The breakthrough becomes a symbol of what can be achieved when patience, curiosity, and care guide innovation. The research team, now more united than ever, prepares for the next phase, a larger spacecraft capable of demonstrating sustained propulsion beyond the laboratory walls. Yet they do so with measured optimism, understanding that true progress is a journey, not a rush to results. And as the sun sets outside the facility, its light reflecting softly on the smooth surfaces of the prototype, there's a shared sense that something beautiful has begun, a future where humanity moves not with force and haste, but with the quiet elegance of understanding, curiosity, and hope. And so, Maxwell's revolutionary spacecraft rests, ready to carry the dreams of a species that has always looked to the stars. The first chapter of a new era is complete, and yet it is only the beginning. For in the silent, steady pulse of its electromagnetic heart lies the promise of exploration, discovery, and the gentle unfolding of human potential among the infinite expanse of the universe. Xiaototech, where innovation meets the road. The future of mobility starts here, only on Xiaototech. Thanks for watching. Don't forget to like, share, and subscribe for more fascinating stories about Elon Musk, Maxwell, Tesla, and the future of innovation. Until next time, keep imagining the impossible.